Good morning.
Yeah, good morning, Prof.
Okay, good morning, everyone.
Good
Okay,
morning.
today I will be in charge of the session, and we are going to discuss on the topic of data collection. However, maybe after the talk, if you have any other questions related to any part of your PhD, you are welcome to ask. Okay,
Thank you, sir.
just to introduce myself, my name is Azmi Aris. I am from Department of Water and Environmental Engineering from School of Civil Engineering. And currently I am attached to the Institute for Sustainable Environment.
Okay.
So I have been with UTM for 31 months. So hopefully the experience that I have in supervising my student and so in examining the student will be of helpful for you to progress in your PhD work. Okay, I think I will start my lecture now. I will turn off my video because it consumes more line so that it will become not slow disturbed by the size of the byte. Okay, if you haven't scanned your attendance, the QR code on your left, and also it will appear in some of my slides later on, so don't worry if you don't get the opportunity to slide your attendance now. Okay, we are going to talk about data collection. So data is something which is very important in your PhD or research work. Without data, then there is nothing in your PhD work that you want to present. So data collection is an integral part throughout your PhD journey. And it is very important. Yes.
Sorry for interruption. Would you please record this session?
Yeah, it is recorded.
Okay, thank you,
Yeah.
Professor.
Okay, where was I? Okay, so data is a very integral part of your PhD work. If you do not have sufficient data or your data is not credible to the eyes of the examiner, then you are in big trouble. So that is why it is important in your PhD work to ensure that the data that you collect is reliable and also sufficient to be analyzed, especially with regards to the objective of your study. Meaning that before you can collect any data through whatever form, okay, depending on your study, whether it is experimental or modeling or maybe surveying. So before you start collecting any data, it is very, very important that you must make sure that your objective is correct. You fulfill the novelty, there is novelty in your PhD work, and the data that you will collect follows a standard procedure or procedure that are expected by any PhD student. Yasin. No? Okay. Yes, please, Yasin. Anybody got anything? No? Right, okay, I will continue. Okay. So that is why throughout this course, data collection comes about in the middle. You have to know how to identify your problem. You have to know how to do your literature review. You have to know how to identify your experimental or your study procedure. Then only it comes to data collection. Anyway, since as I mentioned just now, if you have any question even related to those lecture that you have listened earlier, please feel free to ask, but maybe later after I completed my lecture. Okay, let's talk a little bit about data. So what is data? Basically, it is a collection of facts. Okay, it is a collection of facts. It can be numbers, it can be words, it can be observation, or even description of anything. Okay, they are all defined as data. And depending on your PhD work, different people will collect different kind of data, and this is very relevant to your objective of your study. So there are two types of data. One is what you call quantitative data. So of course, this is what most of the engineers refer to. It refers to numbers. And the number can be decimal, real number, or it can be decimal number. It depends on what you want to collect. For example, if you are working on transportation, maybe you want to count the number of cars, lorry, or whatever transport that is passing through. Or if you are working in the medical medicine field, maybe you want to look at the patients. Or if you are looking at the price, or maybe if you are hydraulic engineer, you may be looking at the flow rate. Or if you are structural engineer, you may be looking at the strength of a beam. Okay, these are all classified as quantitative data. Another one is what you call qualitative data. This is normally relevant to those who do their work in terms of normally those who follow the social science approach. So normally they deal a lot with qualitative data. And qualitative data refers to quality of something. It can be description of colors, or it can be description of experience. It can be description of feelings. So all these are all qualitative data. Okay, maybe for some of you who want to work with human perspective, so maybe qualitative data will be more relevant to you rather than the quantitative data. The other data is categorical data. This is very basic. Also apply to those who normally work with using social science approach. So normally if you want to do some survey, you will collect this categorical data. You want to know their gender, you want to know their age group, you want to know their educational level, their salary. All these are categorized under categorical data. So these are the type of data that researchers will be dealing with depending on their area. And when we talk about quantitative data, as I mentioned just now, there is what you call discrete data or whole number data. Okay, number of cars, number of patients, number of students. So they are only whole number. You don't have 5.1 number of car or 5.7 number of patients. So they are all whole number. And the other one is continuous data. So this is what most of us deal with for engineers. It can be with decimal, with second point, for example, 4.32 meter cube per day, and whatever value. But it is very important also when you collect your continuous data, which is based on measurement, you should know what significant figures are relevant to your work. Sometimes you don't need to have any significant decimal places at all, or sometimes you need up to 5 decimal place. So you should know which decimal places is significant, up to what decimal places is significant for your work. For example, if you are measuring pH, there is no need to state that the pH of the water is 7.3576. There is no need to do that. It is sufficient to say that the pH of the water is 7.3 or maybe 7.34. Yeah, okay. So depending on the work that you are doing, that decimal places is also important. Okay, you don't simply put whatever decimal place that you want to you measure. You must have a reason why you need to have up to 2 or 3 or even 1 decimal place. Okay. In terms of type of data, this is important, yeah. In terms of type of data, there is what you call secondary data. This is the data that you collected from other researchers. And another one is the primary data. This is the data that you produce yourself. You go and collect the data yourself, either through experimental work, through field work, or through whatever approach. So there are two types of data, secondary and primary data. Both are important. Some study, most of the study will require secondary data to start off. Okay, I can say that all study will require secondary data to start off. Okay, for example, if you want to design something, you want to design with a certain volume, so you must know why you pick that volume, or why you pick that flow rate, or why did you pick that strength. Your primary work involve all this, but in order for you to select any values for your volume, for your flow rate, there must be a reason for that. You must be able to justify why I use that value. And justification to use that value normally come from secondary data. Okay, you have done a lot of literature review, and from your literature review, you have found out that studies had been carried out from this value to this value. So yours are within this value. Or maybe you want to try value which is outside the value which is commonly used by previous researcher. That can also be done, provided that you have a good justification to do that. Okay, so what I am stressing here is that although your work may emphasize a lot on primary data, secondary data is necessary before you go to the primary data. But there are some researchers where they rely heavily on the secondary data. They don't have any primary data. This normally falls under those who work heavily on a mathematical model. Okay, their work is to develop some mathematical model, or maybe some physical model as well. So they do not have any, normally numerical model, and they do not have any time to collect primary data. So they normally rely on secondary data. Maybe their model, the calibration of the model or the validation of the model depends on the secondary data produced by previous student or previous researcher. That is also allowed. Okay, so either one, it depends on your PhD work. You will rely mostly on primary data with the help of secondary data, or you will work heavily on secondary data because your other works your main work does not permit you to collect primary data. That is also acceptable. Any questions so far?
No, I don't have, sir.
All right, okay. Quiet mean everybody understand.
Yes.
Okay, few seconds. Those who have not scanned their attendance. Okay, let's talk about secondary data first, because normally, as I mentioned just now, you will start off with secondary data. Okay, secondary data is data that has been collected from someone else. The advantage of having secondary data is that you don't have to collect that data on your own. Okay, as we will mention, we will see later on. As we will see, primary data collection involves time and money. So if you do not have any money to collect the data, then you may have to rely on the secondary data. So in this case, you can take advantage of the secondary data that has been collected by other researchers. Of course, you have to acknowledge them. You cannot take secondary data and say that that is your primary data. That is very unethical and very wrong. And as mentioned just now, for primary data will need money to produce. So most of the time, the secondary data can be available freely. But in Malaysia, some secondary data has some cost. For example, if you're working with meteorology data, then that meteorological data has to be bought by from meteorological department. They don't give you free data. But other than that, most of the data are basically free. It is that you have to ask from the appropriate agency for the use of that data. Okay, save time, save money. And normally when we want to collect secondary data, one of the reasons in collecting secondary data is because the data that we need is a long-term data. Okay, for example, if you are working in hydrology, if you want to look at the flood pattern or rain pattern, normally it will require like 20, 30 years of data. So that is normally cannot be done by yourself. And you ask from appropriate department, and normally that department they record the data accurately. So they put a lot of effort on that. That is why some of them has to be paid. So you can rely on that data. Of course, however, there is a need for you to analyze the data again, although you can assume it is accurate, but there are times when the data is also a little bit inaccurate and you need to do some analysis to look at the outliers and so on. Okay. So there are many sources of secondary data. The main source of secondary data is through journal and conference article, and also previous report and thesis. This is the secondary data that you will rely on before you start off with your primary data. As I mentioned just now, if you want to set up your experimental work, every value, method, approach that you use must have reference. You cannot come out with your own method. Okay, you must use established method, established value, established standards. So that come from previous work, which are normally published in journal and conference articles, and also in previous report and thesis. That is why when you write your thesis, it is very important that your procedure has to be very detailed. Okay, your procedure, your methodology has to be very detailed so that other new researchers who want to do the same work, they can refer your work as their reference. Okay, so this is the important source of secondary data if your work rely a lot on primary data. And this is what you call literature review. And literature review for PhD normally requires a lot of extensive review, maybe 100 to 200 articles need to be read and then need to be compiled and rewrite in your literature review chapter. And again, this is the sources of your for your procedure that you will discuss in your chapter 3. Other than that, okay, if your work heavily rely on secondary data, so these are some sources of your secondary data. Okay, either from federal and state agencies, from companies, from foundation database, or now we have a global database that can also be your source of secondary data. Okay, what are the limitations of secondary data? One is that some data may not be as recent as what you want it to be. Okay, for example, you are doing a PhD in 2021, so you are hoping to get data up to 2020, but sometimes this data may not be available. The data that is available to you may be 2 years behind, maybe 2018. However, if this is the limitation and that is the best data that you can have, so you can use that data. But if, for example, you're working on 2021 and the data is up to 2010 only, then that data is definitely outdated. Okay. Another thing is that sometimes the secondary data is not long enough for you to detect the trends. For example, if you are working with climate change, that will require a very long time data. And sometimes that data is not available to us. But this is something that you cannot do much. So if that is the case, then you have to find something else which can be reliable. And sometimes the data set is also incomplete, missing information on some observation, and some results of the analysis can be biased. For example, for my case, I'm working with water quality data, and for rivers, okay, water quality data for rivers, we have our Department of Environment, which collect data quarterly at their sampling point. So, of course, if you want it for a long-term data, they have data maybe up from 2000 until 2020, which is quite a good long-term data. However, because they have they collect the data only quarterly, January, April, June, September, like that. So the data may not cover all other months that you want to look at. Okay, it may not be a complete set of data that you can refer to. Of course, it is a good data, but you need to collect some other data to confirm their data. And then some of the data may be biased. For example, if the data is only collected at certain time, then the data will be only biased for that particular time. You do not have the analysis will not be complete. Okay, and also the point of sampling that they use for the collection, for data collection, can also be a confounding problem for the data. And of course, if you are looking at the experimental work from other students or other researchers, you must make sure that they have some control experiment where your judgment can be better made with a control experiment. If there is no control experiment, then that judgment will be biased. Okay, other limitation, are the data consistent or reliable? Especially when we talk about rainfall data, there may be times where the data is not available, but luckily for hydrologists, they have method to fill up the gap. And is the information exactly what you need? Okay, if this is also important. They may have the data, long-term data, and a very timely data, but unfortunately that particular variable parameter that you are looking for is not available. So that is something which you need to identify as well, and that may be the setback of the secondary data that you have. Okay, are they reliable, correlate to what you actually want to measure? Can you, from the data, can you do any correlation to get the parameter that you are looking for? So those are things that you need to analyze. Okay, any question on secondary data?
Yes, Prof.
Yes.
When you mention about data that can be biased due to lack of controlled experiment, is there a way to know from a data whether a controlled experiment has been undertaken on it or not?
Okay. Normally, if you're talking about data that you collected from previous student, okay, then
Yes.
that is normally mentioned in their thesis or in their report.
Okay.
Okay, but if it is something which actually, if you feel that the data, there is a need for you to know if there is any control experiment or not, it is you should ask from the data producer. Okay, you should ask from the
Yes.
data. If there is no information whether the data is properly controlled or not, it is very important for you to ask them nicely, of course.
Thank you, sir.
Okay. Any other question?
Hello, sir.
Okay, all right.
Hello, sir.
Yes, yeah.
My question is that concerning the outdated data,
Okay.
is there any minimum and the maximum year that can make the data to be outdated, or is just 1 to 10 years or 7 years or something like that? Or is there any specific minimum or maximum years that can be referred for a data to be outdated?
Okay. When we say outdated, it means that the data is too old to be used. It's not the number of the data. Okay. For example, if you are talking about this may not be related exactly to your data, but for example, in producing your problem statement, okay, in your producing your problem statement, one of the important aspect is the gap of knowledge. Okay, one of the important aspect is the gap of knowledge, which will highlight the novelty of your work. So if you are working on 2021 and you are saying from the sources of 2010 that not much work has been done on this area, so that particular statement is not valid, because the reference that you use is very old, it's outdated reference, 2010 reference. Okay, so if you want to say that this work has not been carried out by previous researcher, then you should be referring to a statement that has been produced in 2020 or at least 2019. Then only that statement can be reliable. Okay, that is one way in which the data is outdated. Other than that, as I give you an example just now, I am working on water quality, and of course I want to know what is the impact of land use on the water quality of that particular river. But unfortunately, the land use data that I have, let's say this is now is 2021, the land use data that I have is only the latest 2015. And the water quality data that I have maybe up to 2012. So how can I use that data to work on the impact of land use on the water quality, because the data is not the current one, or maybe close to the current time of my work. It is too old. Okay, so that is what I meant. I gave you two examples. One is when you do your write up on your on your problem statement. It has to be very current. For example, this is also important. You start your PhD in 2021 and you finish in 2024, for example, right? And then, of course, in 2021, when you do your literature review, the best latest information that you get is 2020. But when you graduated in 2024, when you produce your thesis in 2024, that data is no longer current. You have to produce the statement by referring to 2023 or 2022. 2019, 2018, although it was very close to the time when you begin your PhD, but when you produce your thesis, that information is no longer valid. So make sure that you updated your literature review. That is why when you produce, this is something else, when you produce your thesis, it is very important that before you produce your final thesis, you have to update all your literature review. Okay, and for example, maybe the thing that you said is the same thing, but previously you referred to some paper in 2018, and the same statement actually can be referred to something of 2023. So then it is better for you to update your paper up to the most recent publication, which is close to the date of your thesis production. Okay.
Yes, sir.
Okay. I hope everybody got it.
Thank you.
Okay. Now we go to our primary data. So I believe most of us will be working with primary data. So this is a very important work in most research work. Most important step in your research work. Okay. The advantage, of course, this is yours. Then people will refer to you. Okay, it is your own data. You should be proud of it. But in order for you to be proud of it, you must make sure that that data is reliable to be cited. Okay, that data must be reliable to be cited. People can believe your data. If there is a doubt in how you collect the data, then your data is not reliable. And you will have hard time during your viva to justify your data. So make sure before you collect your primary data, everything is has been looked into so that there's no loophole that people will question your data. Okay, so these are some example of my work because I'm working in an environment. So we collect data, we go fishing, we collect our flow rate, our own selves. Okay, but the main limitation with the primary data is that it will require time and money. You must make sure that your data collection can be finished in a year. Looks like a long time, but actually when you start working, you may feel that 1 year may not be enough. Okay, so planning in developing, in collecting the data is very, very important. Of course, we can plan, but sometimes our plan doesn't work. So we need to have many plans. Plan A, plan B, plan C. Hopefully you don't have to go to that many. But you have to have a backup. Okay, so primary data collection will require time and money, especially if you're working on experimental work. You must have money to set up your rig. You have money to buy your chemicals or materials before you can do the experiment. And even if you are doing site work or survey work, you must also have money for your traveling. So this money, luckily, is normally provided by your supervisor. hopefully he or she will have some research grant to assist you in producing whatever chemicals and materials or traveling money that you require. But still, time is yours. And you don't have all the time. If you want to finish in 3 years, you should allocate 1 year for your experimental work. Why 3 years in PhD? 1 year is for your literature review, okay? Literature review to identify your gap of knowledge and the novelty of your work, that nobody has ever done anything on what I'm doing now. And then the second year, and also on the first year, you also prepare your experimental work, what I should do, this and that. And then the second year, you work on your experimental work, collect the data, analyze the data, and then the third year is for you to write your thesis. Hopefully by end of the third year, you should be able to submit your thesis. So you need time and money. Okay, there's a question. If I write a conclusion, which is originally from a paper of 2015 and is cited in the following year, 6 years up to 2021, and now I'm writing the statement in my thesis, so which one should I cite, the original or the latest paper? Okay, what you can do, you can cite both. Okay, you can cite both 2015 and also 2021 paper. But make sure that the material, if you look at novelty, is novel. Okay, you need time and money to conduct the experimental work or field work, and also to do analysis. Analytical work will also require money, and this is sometimes quite expensive. Hopefully, you can do the analytical work at UTM, but sometimes if they are not available, you may have to do it outside UTM. You have to ask other people. It is okay to send your sample to third party. It is acceptable, provided that that is advanced analytical work. If it is basic analytical work, you have to do it. But if it is advanced analytical work, you can ask third party to do it, but you must state that in your thesis. And also, although that work is being carried out by the third party, you should understand how it is being done. Okay, you should know and you should understand how it is being done, because you also need to write the analytical procedure in your thesis. Although that analytical work is being carried out by other researchers, by third party. And that will require money, sometimes thousands of ringgit, just for one sample. Okay, you need money to design your collection instrument. You need money to do some pre-testing or piloting the instrument to make sure that there is no bias, or to do some calibration with the instrument. Maintenance of the instrumentation, maintenance of your rig, all those require money. And sometimes if the data are too much, you may not have enough time to do it, and you have to ask assistance to collate the data, then that is also require money. And of course, other things. Okay, so these are the two primary limitation for the main limitation for primary data, which is time and money. If you have time, if you have money, then it's fine. If you don't, you have to work on it. But for time, you have to allocate time for it. Okay, another limitation of primary data is that sometimes your work is too novel, it is very unique, and because of that uniqueness, you are not able to compare it to previous work. So how can you be assured that your data is correct or not? So that is also something which you may want to think about. Okay, it is allowable, but it needs a lot more thinking on how to discuss on your results, because normally when you discuss your results, it is important also you compare your data with previous study. Okay, and then make sure that you reduce the error. Okay, there are lots of researcher error. It can be bias in your sampling, some confounding factors which you forgot to identify before you start your work, and not having, this include not having control experiment. This is also a very big mistake. Okay, so please make sure that if you are working on experimental work, you should have control experiment. Okay, for example, if you want to look at the effect of material A on the strength of something, so you should have a control experiment that do not have material A in your experiment. So it is very simple. Just having something void of the one that you are looking at. Okay, so that is a very simple thing, but many people forget. And then when it comes to Viva, when we ask, where is your control experiment? No control experiment. So if there is no control experiment, how you can conclude that the effect is because of that particular material? Okay, then you have to do a lot more reading and discussion in order for you to justify your findings. Okay, any question? No? Okay, right. Now we go for methods of collecting data. Okay, there are many methods of collecting data. The most commonly, engineers or scientists, they will use lab or field experiment. For social science, they will use survey. Some they will use observation. Okay, on some social science researcher, they use observation, looking or observing the patient or observing their sample. Some may involve interviewing participant. Some may have to conduct workshop in order to collect the data. Some may be looking at theoretical analysis. Okay, if you're working with modeling, then you will be looking at the theoretical aspect and then develop the model. And also numerical analysis. So these are some of the methods that I know of in collecting the data, depending on your field of work. Okay, if you are social science, maybe number 1 to number 4, number 2 to number 4 is your approach. If you are engineers or scientists, maybe number 1 will be your approach. If you are engineers and scientists working with a mathematical model, then last one, number 5 and number 6 is their approach. So as I mentioned just now, data collection is an integral part of your PhD work. So before you start collecting your data, you must make sure that everything has been considered. Everything has been considered. So before collecting data, you must make sure that you have identified and confirmed with your study objective. But before you reach your study objective, you must make sure that your work is novel. There is gap of knowledge in the area that you want to study, and therefore your work is novel, and you must state this in your problem statement. And in order for you to fulfill the missing gap of the work, so you are doing this research, and this is my objective. So you must have a firm objective. And then you should identify your scope of work. You have only approximately 1 year to do your research work. So you should make sure that can be, whatever study that you want to do can be completed within that 1 year, or maybe 1.5 years if you don't intend to graduate on time. Do not dream too high, because then you will be in big trouble. Remember that doing PhD is not to solve the world problem. Doing PhD is to fulfill the objective of your PhD work, which has novelty. And it should be able to be achieved within very short period of 1 year. So your scope of work must cover this. What is the limitation of your time? What is the limitation of your parameter? What is the limitation of your work? So you have to identify that. And you need to state that in your scope of work of chapter 1. And then you know your objective, you know scope of your work. You also need to identify the variables or the attributes that are involved in your research work. These are the variables that you need to solve in your experimental work, survey work, or whatever. This is the data that you want to collect. And you need to know how to measure that variable. Okay, as I mentioned just now, that method of measurement must be a standard approach or approach that has been used by previous study, that has been validated by previous study. One more. Kong Jo tengah kelas Jo. Kenapa? Oh ya ke? You tak ada kopi ke? Itu bukan you yang uruskan ke? Ya. Ya, saya ni tengah kelas. Okay. Okay. Hai. I need one moment to settle a few things. One moment, yeah. Okay, sorry for the interruption. So okay, we stop at variables measurement. So you need to know all the experimental procedures that involved in collecting that data, and then also method of data collection. Okay, so this need to be finalized. Okay, it is very good if this can be. It is very important for you to finalize this before you start collecting the data. This is a research framework, an example from my student. So it is good if you can have such framework before you start your data collection. Okay, so if you see here, the student, the title is Treatment of Textile Wastewater Using Hybrid Biogranule System. She has already identified these are her 4 objectives. And for each objective, she has identified what she wants to do. What are the variables, what are the things that need to be prepared, and what are the parameters that need to be, the data for the parameters that need to be collected in order to achieve objective number 1. The same goes with objective number 2, same goes with objective number 3. And from these 3 objectives, she will collect from objective number 1, objective number 3, and that will become her objective number 4. So if you can have this research framework before you start your experimental work, that will be great. Because then you know what you want to do, what you want to collect, what you should prepare, and all those things. Okay, so this is something which is important for you to prepare before you collect your data. Okay, some of the principles of data collection. So that photo actually is our technician helping us in collecting fish, because the project is on the impact of land use on water quality, and we are using fish as our indicator. Okay, so principles of data collection: understand and know what types of data required, collect only relevant data, because primary data collection is expensive. Don't collect unnecessary data. That will increase your data collection time and expenses. Determine what method you will use for your data collection. And identify also where you will collect your data, who will be helping you to collect the data, how are you going to collect the data, and when you should collect your data. Okay, this where, who, how, and when is very much dependent on your research design, on your sampling procedure. And then you also need to prepare, if you are working on fieldwork, you need to prepare your fieldwork schedule and data plan. And also you need to conduct preliminary investigation. For example, before these 2 guys go and get the fish here, we need to do preliminary investigation to see whether that site is suitable or not suitable for us to get into the river, or is there many fish or no fish at all. Okay, so all those has to be done before you collect your actual data, meaning that you need to do some preparation work before you start collecting your data, and maybe need also to do some pilot study. And then you also need to anticipate problem. Okay, what if what I plan doesn't work? Okay, you need to have some contingency plan in order what you want to do cannot be fulfilled. This happen very, very often. So don't expect things to flow smoothly. Okay, there will be lots of headaches, there will be lots of difficulties, things that you plan doesn't work, you anticipate the results should be like this, but it doesn't come as it's supposed to be. Where does the problem come from? So these are all things that you need to anticipate, and these are the things that will slow you down, and that is why at least you need 1 year period to collect your data. If you are working on experimental approach, okay, this is, for example, an example of my student reactor, can be fieldwork or lab work. So you need to know the number of samples that you need to take, the location of samples that you need to take, when you need to take, how frequent you need to take, how long you should take the sample. So these are all things that need to be considered before starting anything. Okay. Do my experiment requires me to take sample for 24 hours, hourly basis, or is it sufficient to take maybe 4 hours interval, or maybe I should take samples more frequent in the beginning and then less frequent towards the end? How long I should let my experimental run, my experiment run? So all those actually you will know from your literature review. Your literature review, previous study, people, they write their methodology, they write their procedures, then you can learn from them how to do your work with or without modification. And as I mentioned just now, should I have control experiment? Should I use experimental design? Of course, you should use experimental design, whether it is statistical experimental design or non-statistical experimental design. You should judge yourself whether you should use a statistical approach or the traditional approach. And if I want to do analysis, what type of analysis that is important to answer the objective of my work? Okay, and I will talk later on this analytical work and testing. So if you talk about experimental design, there are many approaches of experimental design. The traditional one is what you call one factor at a time. The statistical one, you have a mixture design or response methodology approach. And the response surface methodology, there are two commonly used methods: central quotable design, and the one is box beacon. And if you want to do optimization, it is better being done statistically. Okay, so this is old fashioned, one factor at a time. But now people are moving towards this experimental approach. This is a statistical experimental approach. But you need to understand why it is being done, what is the weakness, what is the advantages. And although you are using this statistical approach, actually the main important aspect is not the approach itself, but the understanding of what of the phenomena that happen behind the process. Okay, don't get too much involved in the statistical analysis without understanding what is happening behind the process. Okay, this is one factor at a time. What normally people do in one factor at a time, they have, for example, 6 experiments with a certain variable keep constant, only change variable, and from that experiment they get the best value for that particular variable. So they continue with the next experiment, 6 experiment again. The one that they have identified in the first experiment being used for the second experiment, and then they will vary other variables. And then they got, now they got 2 values for 2 variables. So the third experiment will use that 2 variables that has been identified, and then the rest will be varied, so on and so off, so on and so forth. So one factor, you change one factor at one set of experiment. The problem with this set of experiment that you did not test the variables at other values. The value that you test is very, very limited. So you will not be able to cover the whole range of experiment. So in order for you to do a better approach is to use this approach, what they call response surface methodology. Okay, response surface methodology, you will be able to normally people will use design expert or Minitab or statistical software. So three variables which they have this to different value, which is given by the software, and from there they run the experiment in certain orders, and they will cover a certain aspect of this rate value of the experimental region, and from there they will be able to have these plots, 3D surface plot. And this is a much better approach than the one factor at a time. And then from this, you will go to a next step, which is to optimize with many variables. This one you are only optimizing with variables, but if you have 4 variables, you have to go to another stage, which is called optimization. Then that optimization will be able to help you to optimize or for your response, and also for your 4 variables at one time. So you will learn this later, but this I'm giving you some of the approach that can be used if you're doing experimental work. But normally this deals with the experiment which do not take lots of time. But if your experiment take lots of time, maybe this approach may not be suitable. Okay. Again, for the analytical work and testing, as I mentioned just now, you must use standard testing method. Or if there is no standard method for that, the method must be referred to previous work that has been justified or it has been reviewed. And then your experiment need to be calibrated as necessary. Some experiments require frequent calibration. Some experiment will require maybe every 1 year, some maybe every 6 months. But the important thing is that you must make sure that whatever instrument that you want to use has been calibrated and also reliable. Okay, and this normally talk about the quality of the analytical instrument. The more reliable experiment and analytical work is normally more expensive. But make sure you have a good instrument to analyze, and also the accuracy of your analytical work. And accuracy means that if you test you do the three testing, so you take one sample and you analyze it 3 times, so the value should be about the same, around the same. Okay. And as I mentioned just now, most of the time we will be using internal lab, but if your lab does not have the capability to do the analysis, you can do it outsource. You can outsource it, but make sure you mention that in your thesis, and also make sure you also understand how it is being done. That is very important. Okay. Any questions so far? No. Okay. Everybody
Yes, bro.
understand?
I have a question.
Right. Good. Okay. All right. Yes.
On this response-based methodology, the software you just presented, sir, the probably when you have like when you have a topic and you want to use that software, and based on the previous researches that you saw on maybe your literature, based on the extensive literature review, and you haven't seen any software, you haven't seen any paper that was used, that the response-based methodology was used. So can you think of maybe initiating your own idea of using the software on that area?
Okay. All right, good question. That's all?
Yes.
Okay, all right, that is a good question. Actually, before I answer your question, I want to go back to novelty, because what you mentioned just now is something related to novelty as well. Okay, what is meant by novelty is that the work has never been done by other people. Okay, nobody has done that work before, so you can consider yourself indulging in a novel work, but you have to be very careful. Okay, you have to be very careful to claim that I am working on a novel work. For example, if you want to fish in the ocean, okay, so there are some popular areas where people like to go fishing, but there are some remote area where people don't like to go fishing. So you may claim that, okay, this area, nobody has come to that area, so maybe I should go there. Similarly, like you said, okay, nobody has done that, so maybe I should do that. But then before you start venturing into that, you have to ask question, why have not people do it? Why didn't people go to that area to fish? Maybe because everybody knows that there's no fish there. That is why nobody go to that area. You think that you are doing novel work, but actually it is not about novelty, but actually you're doing something which is stupid, because everybody knows, because you are new in that area. People have dealt in that area for so long, so they know that there's no fish here. So there is no point for you to go fishing, although there is no fisherman there. You think that, oh, there's no competition, so I should go there. But actually, why they didn't go there? Because there's no fish. Okay, so similarly, if you see people not doing anything on that area, so you must stop for a while and think why people have not done that. Is there any reason? Maybe they do not work on response surface because your experimental work is not meant to use response surface method, meaning that maybe the experiment takes too long, and if you work on response surface method, you will end up taking so long time to do the work. For example, like this, yeah. Okay, I am working on biological process. Biological process means using microorganism to do my treatment, to treat wastewater. In biological process, people has never done response surface method. Because why? Because microorganism, they are not like chemical process. Chemical process, microorganism, they take a long time to adapt to the environment. Okay, they take long time to adapt the environment. So if you do it using response surface normally is a very fast experiment. Okay, you say, okay, for 3 days, I will use this approach. Another 3 days, I will use this approach. So the problem is that within 3 days, your microorganism are not well adapted to the new environment. So whatever findings that you get actually is a false finding, because the microorganism has not adapt to the new environment, so the results that they produce actually is not correct. Okay, so in that case, nobody has done statistical approach in biological treatment. So if I come and say, oh, nobody has done, so I should use response surface, then actually I am like going into the area fishing when everybody knows that it doesn't work there. Okay, so did I answer your question?
Yes, bro.
All right, sir. Okay, so not only on your question, but when you talk about novelty, when you see a very green area nobody has done on that, please don't immediately grab it, sit down, think, look deeply why people has not ventured into that. If you get a satisfactory answer and you still think that it is valid for you to venture into that no one area, then go ahead. But you should have a good reason to justify it later.
Okay, Prof. So another question, Prof.
All right.
There was a paper I saw somebody suggested that mathematical modeling should be used as maybe as of like he's recommending that further research should be carried out using mathematical modeling analysis. Then I tried to search whether that mathematical modeling analysis was used for that particular topic. The same thing, I couldn't find any paper in respect of that. So in this case, is that one a novelty? One, or how do you find a mathematical modeling analysis that can suit the area? Or at the same time, is that a novelty or not? Thank you, Prof.
Okay. Actually, when you talk about mathematical model, there are two things. One is developing a mathematical model, and the other one is applying existing mathematical model. So applying mathematical model is something which is not considered as novel because the model is there and you just apply it unless that application, model application has not been done before. Then and provided that the condition allowed for the mathematical model to be applied. But if you are talking about developing a mathematical model, this is a big, huge work to develop mathematical model. And most of the time, people who develop mathematical model, they are doing it as a sole, that is their main work. They don't do any experimental work. And as far as I know, if you are asked to do mathematical model, normally part of mathematical model is to calibrate and to validate your model. So normally that calibration and validation of model is based on existing data. So developing a mathematical model is normally carried out if you have sufficient data to use to calibrate and validate. And that should be your main work. But if you are talking about developing mathematical model to validate your experimental work, I don't think you will have sufficient time to do that. But in terms of novelty, I think it has to be looked into further. I'm not so sure if I can say that it is novel or not. But again, as I said, why people have not done it before? This is already 2021. Mathematical model is not something new. So why have not people ventured into that? And if you want to venture into that, can you do it in a year or 1.5 years? Okay, so this is something that need to be considered.
Okay, Prof. Thank you so much.
Okay, all right. Any other question? Okay, let's move on. Okay, this is for non-experimental or social science approach. So for those who are not scientists or not, or even especially for those who are working on construction management or even some other work, sometimes they are scientists, but they work on social science approach. So this is their approach. Either they use observation, they use testing their sample, they do survey, they do interview. Survey and interview are two different things. Survey is normally the sample for survey are a lot, maybe 1,000 samples. But for interview, maybe it is very selective. And observation is also selective, and the same with tests. Or maybe you need to get input from experts, so you do workshop. Okay, normally they have a focus group workshop or stakeholder. It's all the experts or those people they want to get info from. So they have them discuss, they put their question on them, and they do the discussion. And from that discussion, they record, and then they put it into words. So that is how they collect the data. And if you're working on history, so normally you would be looking at document analysis. So instrumentation for the for social science, they use questionnaire, or they have interview checklists. They have, if they are doing observation, they have their observation form. They prepare the form first, what they want to observe. It is not just simply come and observe. They must plan first what they want to observe. And they should have a scale point, and then content analysis form from what they hear from their samples. And then maybe some depend on what they want to achieve. They have the achievement researcher design achieve. They have tests. Okay, they conduct tests, and they have this needs to be designed. Okay, and their approach of design, the social science approach of design, is very different. Actually, I do not know much of the social science, but I have some experience listening and just trying to understand my colleague in their approach. For example, if they are doing survey, okay, they actually have to prepare sample. They have to collect their sample, so they need to identify samples. Okay, identify sample is very important so that the output of the survey is not biased. Okay, and the risk of doing survey is that they do not get sufficient response rate from their participant. Traditionally, the survey is being carried out physically. You go from person to person, face to face, or maybe more advanced, you send a survey form by post to your samples. Or sometimes you want to survey the village, so you go to their head villages, you give them all the samples of the forms, and then the head villagers will assist you to collect the sample from your participant. But nowadays, because of the COVID, and because people now are more adapt to what they have in their hands, their handphone or computer. So now we use Google Form, or maybe forms that are brought to the participant through email or telephone. Okay, these are the common approach. But whatever it is, whether it is through physical or it is through electronic approach, response rate is still the key survey parameter. And later on, we will see how many samples are needed in our study. And normally, if you require around 100 samples, you will work on maybe around 500 survey form, because it is quite difficult to get all those form back to you. So normally, the number of form that you discharge is much higher than the number of response that you require. Okay, so it is being administered through, as I mentioned just now, personal interview, telephone, or maybe a questionnaire. So for questionnaire, if you are doing a survey questionnaire, keep the questionnaire as short as possible. Okay, people don't like to spend time. For example, if for me, if I receive a survey form say that, okay, this survey form will take 30 minutes for you to fill up, then immediately I will not fill up that questionnaire. But if it says it will take about 10 minutes, then I have my tendency is to answer. But then if it is more than what is being mentioned, then I may not answer it completely. Okay, so it is very important to keep the questionnaire as short as possible. Ask short, simple, and clearly worded question. Okay, make sure that the question is very simple to understand, especially if the question is to address villagers or people or laymen. Don't use jargon, things that laymen don't understand. Normally, we start off with demographic question. This is the categorical data which I mentioned just now, where how many family members in your house, how much do you earn, how old are you, from giving range from one value to another. This demographic question is not only to start the survey question comfortably, but it also will be used later on in your analyzing the data. Maybe from the level of education, you will know how this level of education relate to their environmental awareness, for example. How their salary relate to their action. Okay, so this not only for comfortable start, but can also be used in your data analysis. Okay, you can use yes or no, and you can also use multiple choice questions. But if you want to make the participant answer freely, make sure that it is not too open. Because if it is too open, then you may not be able to achieve your objective. Okay, they may answer anything that they feel, and it will not focus on your objective. And also, in spite of that, we should not use leading questions that we expect them to answer certain. We should not be biased. Okay, we should not be biased. The questions should be able to. The main thing is that the question should be open ended in a way that you should be able to get a good conclusion from the questionnaire. And it is good that the questionnaire are being tested first. And in some situation, this questionnaire need to be validated. Okay, this questionnaire need to be validated by experts. This is important because as far as I know, this validation process for questionnaire is sort of a requirement in the Viva. Okay, they will ask whether has you validate this questionnaire, and if you say that you have validate, they will ask who validate the questionnaire. And then only then they will be happy with your questionnaire. Otherwise, they will question the validity of your questionnaire. Okay, and make the questionnaire relates to the data that you want to collect. Okay, in terms of sampling, you cannot do as much sample as you can. It is very costly and sometimes it is not practical. So you need to have sample population. Okay, and you need to have sample population which you get from the target population, which is similar to each other. So although the target population is maybe 100,000, but you have good sample population, so that samples that you survey can be representative of your whole target population. So there are two types of sampling. One is they call simple random sampling, and the other one is called stratified random sampling. Simple random sampling is very simple because it's also named simple. So, for example, draw 3 names from a hat containing all the names of the student in the class. Equal opportunity, no bias. You want to give present to 30 students, so you have their name rolled in pieces of paper, and then you call the headmaster, come and pull 3, let's say it's like lucky number, lucky number event. So this is simple sampling, simple random sampling. Okay, simple random sampling. But this can be difficult if the samples are too many. Okay, another one is stratified random sampling. You have a big number of samples, but you can stratify them into certain categories. Okay, for example, you stratify them first according to gender, then stratify them according to age, and then you stratify maybe according to the occupation. So you have a group of people. Okay, you separate male on one side, female on the other side. And then if you feel that certification is sufficient, then you can random sampling from there. But if you think that it is better for you to certify according to the age, maybe you segregate them according to the age, and then from there you do random sampling. Or maybe based on occupation, or maybe based on salary. So that is called stratified random sampling. Okay, this is an example. If you have under 5,000, the population portion is 75%. So the number is if the number of sample is 400, so those 125,000 you take 100 sample size, and then you do the random sampling. Okay, and the same for 1,000 depending on the salary, you do the stratified random sampling. Okay, the larger the sample size, the better. The less error you will make, but more money and more time is required, and that is our limitation. So normally the sample size is being determined based on the sample population divided by the precision that you want. Okay, divide by the precision that you want. The more precise, the smaller the value of the precision, the bigger the sample size number. Okay, in sampling, there are two errors. One is a sampling error and the other one non-sampling error. Sampling error refers to the difference between the sample and the population. Okay, that exists only because of the observation that happened to be selected for the sample. So this is the difference between the sample and the population. So in the population, there may be loss of stratification, and you don't realize that. So you choose a small number of sample, just sufficient enough, but there were mistakes in your selection of sample. Your selection of sample may be on certain group of people only, so you miss the other group, so you are not able to get a good conclusion. So this kind of error can be rectified by increasing the sample size. But for non-sampling error, this is something which cannot be rectified by increasing the sample size. This is normally due to the mistake made in the acquisition of the data, or due to the sample observation being selected improperly. For example, this error in data acquisition can be you go and make an interview, for example, and normally when you do an interview, you will have a recorder to record the interview. But it is important that before you record the interview session, you must ask permission. You must ask permission from the interviewee that allow you to record the conversation, because some people don't like to be recorded. Okay, so that agreement is very important. So you were given the agreement to record, and you start recording. After you finish interview and you want to listen back your recorder, you realize that something was wrong with your recorder machine, and all the conversation was lost. So that is an example of how errors are being made in acquiring the data. Okay, so make sure you prepare well to avoid this. Make sure you prepare well before the interview session. Okay, another one is the non-response error, which I mentioned just now. You send all those the survey form to many people, but only few come back. So that is sometimes for me at UTM, we receive many questionnaires, and sometimes the questionnaire come repeatedly to us because they have not received enough response for them to get a valid data. So non-response error is something which is very critical if you're doing survey. Okay, mistakes during transcription. So sometimes after you recorded the conversation, you will transcribe it. Whatever being conversed in the recording will be put into text. So there are occasions, if it is not done properly, there will be transcribing error that will come out with different conclusion. Okay. So these are some of the example in errors in data acquisition. Okay, I mentioned this, and then the selection bias introduced by the selection of individuals, group, or data in such a way that this is the same as I mentioned just now. Okay, that is basically how data collection is being carried out. Then after you collect your data, the next step is data analysis. This will be covered by Dr. Hazilan, Prof. Hazilan later on, but I just want to touch it briefly. When you collect the data, you have the objective before you collect the data. And then make sure that the data analysis will answer all the objective of your study. And data analysis can come in the form of plots and tables, qualitative and quantitative analysis. And then the data should, although the data was not acquired according to statistical approach, but the data need to be analyzed statistically. Okay, again, although the data may not be acquired using statistical approach, for example, the one that I mentioned just now, I do biological process, we don't use RSM or all those statistical approach, but the data that I get need to be analyzed statistically using normally ANOVA table or t-test, whatever test that we want to show, because if we say that there is a difference between this parameter caused by certain variables, then that differences must be validated statistically. Just cannot, by eye view, looking at the plots, looking at the tables is not sufficient. It has to be confirmed, validated statistically using some statistical approach. That is a must in PhD or master by research work. Okay, I think that's all from me. Any question?
Yes, Prof. Yes, Prof. Yes, Prof. I have a question.
Yes. Okay.
Okay, you spoke on assuming a researcher is using a questionnaire, wants to get carry out a survey using a questionnaire. You spoke about validation. Are there certified validators of questionnaires, or you just give somebody that's studied statistics, or that is, or are there international?
Okay. Your voice is breaking off, but I think you are asking who should validate the questionnaire.
Or maybe UTM has certified
Okay.
for that. If you mention them, they will.
So you are asking who should validate the questionnaire, right? Am I right? Because
Yes. Are
okay.
there certified
Okay.
validators?
All right. Okay. I
Are there
understand.
certified validators?
Okay. From my knowledge, from what I learned from my colleague, there is no such certified validator. But how do they do it? For example, if I am doing survey on environmental awareness, for example, so I will ask experts in that area to validate. I will send my questionnaire to different parties, maybe to the Department of Environment, maybe to NGOs, maybe to researchers in the same field. So there will be different type of people that basically they are the experts in that field. Okay, they are the experts in that field, and they know whether the question that I pose is valid question in order for me to achieve my objective. So the answer to your question is that, as my knowledge is concerned, there is no such thing as certified validator, but the one who validate the questionnaire are the experts in the field of your study. Okay?
Okay.
Right.
All right. Sir. Thank you.
No problem. Any other question? Not only related to data collection, but any other question? It's okay.
Assalamualaikum, Doktor.
Salam.
Okay, insyaAllah we'll do questionnaire survey. Okay, let's say if my population is 500 or 1,000, for example, but in current situation, I cannot afford to have that number. So what should I do for the next step?
Is that your N or your actually first just now I show you that number of that number is the minimum sample.
Okay.
Okay, so normally the number of samples, the number of survey that you send is much bigger than the number of sample that you require.
All right.
But as long as your number of samples, minimum number of sample, fulfill that N value, I think that is okay.
All right.
Okay, and then again, the number of samples will be affected by the by precision level. Okay, if your number is small, meaning that your precision is low. Okay, so what is the minimum precision level acceptable in your field?
Oh, okay. One more, Doctor. Okay. For the validation, we have to get we call from industry and academician, or academician is enough?
You have to get it from industry. As far as I know, industry is very important, because industry and academician have different set of mind, different experience. Not only industry, depends on your work. If you're talking about construction, not only industry, but maybe you have to go to agencies, government agencies that are involved in construction, for example.
All right. Okay. Thank you, Prof.
Okay. All right. Any other question? I read from the WhatsApp, somebody was asking about doing literature review and get the methodology, but I don't quite understand what the problem is.
Okay, yes, Prof. I'm the person that wrote that statement, sir.
Okay, all right.
It is it's the methodology is through the literature review as you are going through to see previous work, how they did their methodologies.
Okay.
So it seems to be a little bit tasking going through all the methodologies to go through the work of that researcher to know exactly what he did.
Okay.
Yes, sir.
Through your reading, they have different types of methodology.
Yes, sir.
Okay. So actually, in your literature review, what you can do is to list down the methodology that has been used. I don't
Yes, sir.
think that methodology can come out to that many. Maybe even
Okay.
if for me to have like 10 approach is quite a huge number. But then you can list down this methodology and then you can identify what are their strengths and what are their weaknesses. And then from that approach, you can select which one you think will be suitable for you. I
Okay.
believe that each methodology has their own strength and also their weakness and also the condition. They may have different condition why they select that methodology.
Yes, yes, yes.
So you need to know which one that suit you.
Okay.
Mm.
Thank you, sir.
Okay, no problem.
Yes.
I think
Yes, sir.
I believe
Yes, sir,
that you
Prof.
all, yes.
Okay, I have a question, Prof.
Okay, all right.
Okay. So, assuming you want to carry out a research, you discover that there is a need for, there is a gap in a particular area. Let me use Malaysia as an example. For instance, I want to carry out a research along routes that goes to Johor in Malaysia, and then um, there is no literature to back up that even though after searching there are no evidence that such work, there are evidences, there are no related literatures that such work has been done there, but closer to Johor, maybe another province closer to Johor, such work has been done. Can how do I validate, how do I make it how do I prove that such make the work novel, saying that okay, I can't get literatures that prove that such work has been done there, like the work
Okay.
has not been done in Johor, but
Okay.
closer to Johor, maybe another province that has been done, but I can't get a literature that I know
Okay.
is a problem, in Johor, but there are no literatures that prove that such work has been done there. How
Okay.
do I go about that, sir?
Okay. Okay. You're talking actually about novelty, right?
Yes.
Yes. Okay. So in terms of novelty, place is not novelty. Okay. If nobody has not done something in Johor and you want to highlight that as your novelty, so normally that is not acceptable. But I give you an example. People have done some work in European country, in Eastern country, but nobody has done anything maybe in Southeast Asia. So how does Southeast Asia differ than Europe or differ than Midwest country or West Northwest country? What are their differences? Is that just the name of the place, or is there any characteristic which differentiate between these places? Okay, for example, I'm working on let's say I'm working on water pollution. Many work has been done in US, in UK, in Europe, in China, in Japan, but none has been carried out in Malaysia. It is not appropriate for me to say that there's no work being done in Malaysia. But if you want to do it in Malaysia, I have to look it in different perspective. European, they are 4-season country. Their climate is different. Their climate, their temperature, their rain are different. Their rain intensity. The same goes with China, the same goes with Japan. So the difference between Malaysia and all of this country is that we are in tropical region. So my novelty is that I want to do study that has never been done in tropical region. And of course, I have to search. Has there been anything being carried out in Thailand, in Philippines? Or if there is such thing has been carried out in Thailand or in Philippines, what are the things in Malaysia that make it different other than Malaysia itself? What are the properties that is different in Malaysia as compared to the properties of other countries? Then that can be your novelty. Meaning that just giving the name, okay, there's nobody done anything in Johor. Somebody has done maybe in Selangor. So what's the difference between Johor and Selangor other than the name? What characteristic that you may want to point out? So these are the character that you need to highlight in order for you to identify the novelty. By just saying that, oh, nobody has done anything in Malaysia, then there will be so many novelty. People have never done this in other countries, blah, 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 and other place. So by giving names of the place is not sufficient. You have to understand the characteristic of that place that is different, that can give you a point to highlight, oh, people have not done in this tropical region with high rain intensity, for example. Did I answer your question?
Yes, sir. Thank you so much. I'm
Okay.
grateful.
Any other question?
Yes, Prof.
Yes, Prof. Morning.
I have a question.
Yes.
Okay, I'll go ahead.
Can I want to start?
Anybody? One by one?
Hello?
Yeah, I'm listening.
Yes, I said the issue of methodology that you discussed about, you may discover that you may have a lot of research gap, or you can have like 3 or 4 recommended research gap, but the methodology will be very difficult for you to find. So in this case, how can you advise for some? How can you advise us to like to come up with a methodology? You may have an objective or maybe a research gap that is clearly suggested by previous researchers, but finding out the methodology will be very difficult, or will be like very tedious for you to come up with. So in this regard, sir, or in this aspect, how do you advise us, or is there any way that you can tell us to?
You mean that nobody has done anything to achieve
Yes,
the objective?
yes.
Oh, okay. That is very novel. Okay. Nothing close at all.
You know, there are clues. There's a lot of things that are clues. Can you adopt similar method of that one, or you can?
Yeah, you can adopt and modify.
Okay.
Yeah, you can adopt and modify, but it is good to have justification for your modification.
Yes. Thank you.
Abdullahi? Okay. Any further question? We'll stop in another 5 minutes.
Yes, Prof. I wanted to find out, most examiners or supervisors, especially in the science field, always find it difficult
agreeing with questionnaire in respect to perception. They always
Can you repeat again? Your voice
see it
is
as not
breaking.
being valid enough as a data. I don't know your view towards this, sir.
Can you repeat your question again? Your voice was breaking just now.
Are you hearing me well? Okay, I say most supervisors or scientists always have disparity as regards to questionnaire. They conclude it's just a mere perception and it's not valid enough. I'm seeking your view on this, sir.
Okay. What is your area? Excuse me, what is your area?
My area is science.
Yeah, I mean which in particular?
Water resources and environmental engineering.
Water resources. Okay, all right. Okay. Normally, if your supervisor is a scientist or engineers, and normally their work will be more on scientific approach. This is very related to the field of study. Some field of study will really rely on scientific value. Some work really rely on non-scientific social science value. And there can be some who sit in between, but that is not many. So it depends. It really depends on your area. That is why I asked you your area, because if your area is scientific area, then normally the expectation is that your study will be on the scientific approach and scientific results. But if in your study you want to combine between scientific and social science approach, where you want to have that kind of approach, but then there will be question, because in doing PhD, normally we are going in depth rather than abroad. If you combine between social science and science, it looks like to me you are going broader, which is not normally acceptable in PhD or master by research work. So it is either most of the time it is either way, scientific approach or social science approach. Your supervisor can be a scientist, but he can also ask his student on social science approach, provided that he has a co-supervisor from social science background. Okay, those who are having that knowledge, he can do that, but he need to get somebody to assist him, because we as scientists, we don't have fully understanding on how the social science work, and normally you will be examined by social scientists rather than scientists. Okay, I don't know if I answer your question, but that is the condition which I feel taking place today. I have friends who are chemical engineering, but her approach, she works on both sides.
I actually carried out.
I cannot hear you.
As I'm fine with
who's talking? Your voice is.
Thank you.
I cannot hear anything. Maybe if you want, you can write down on the chat box. Okay. Nobody got any question? Okay. I think we already reached.
Professor,
Yes.
the record, will you send it to us in the WhatsApp
yes.
or?
Yeah, yeah. I will share with you either in WhatsApp or in the e-learning. Either way.
Okay, thank you.
Okay. All right. Okay. Thank you very much. Take care.
Thank you, sir.
All right.
Thank you.
Prof, can you share your email address for us?
Okay, sure.
Your email address on the WhatsApp, sir.
There's my email address. I am also in the group WhatsApp.
Okay. And the contacts and your contacts, sir. Thank you, sir.
All right.
Thank you.
Thank you very much.
Thank you, Prof.
Okay. All right. See you then. Take care, everyone.
Bye-bye.
Okay.
Bye-bye.
Assalamualaikum warahmatullahi wabarakatuh. Have a good day.
Welcome, sir.